Hello students, Mr. Alexander here. So this is Lab 1, our Introduction to Measurement and Strategies for Collecting and Dealing with Data. So we went over the first few pages of this in class. Just to review, you have some blanks here. So after you read the first paragraph, you want to fill in those blanks. So for instance, 10 millimeters is equal to how many centimeters? And the answer is 1. And continuing on, you want to fill in the rest of the blanks that I listed on your handout. Down here, we've got some common prefixes, like mega, meaning million. You want to fill in the number for that. So since it's a million, that'd be a 1 with how many zeros? 6. Kilo, think about what that means. Centi, these are all the common prefixes that we use in science, not just in physics, but just in high school science in general. You'll want to try to memorize these. So if I was trying to memorize them, I would maybe cover up a column and quiz myself and see if I know what the symbol is, what the factor is, right? Think about that. That's for scientific notation. What the number is, and then what the name is. Right? So quiz yourself, try to memorize these. We're going to use them a lot, especially kilo, centi, and milli. Those are some big ones for us this year. Okay, moving along. Here's another unit conversion. We've been practicing these in class. You should have an answer for that right here. And precision and accuracy. I think most folks have that down pretty well after our last class. Uncertainty is a little bit tricky, but the idea here is, let's say you measure your height and it looks like it's about 5 foot 6 inches, but it could be 5 foot 5 inches. You're not quite sure, then you say, like they wrote here, give or take. I think I'm 5 foot 6, but I could be off by an inch, so you'd say 5 foot 6 inches plus or minus 1 inch. All right, you're just expressing how unsure you are with the answer. So the way we do that in my class and in science in general is that we say the uncertainty is 1/2 of the smallest division. So what does that mean? Well, let's say that the smallest division, like here, is 1/10 of an inch. All right, like here, then we would say our uncertainty is 1/2 of that 1/10, or 1/2 of a 1/10 is 0.05. That's how we would express that. So you'll use that rule throughout the class this year. Here's how you calculate error. We talked about this in the flipping physics video that you watched last class. And now it's where you get to practice a bit. So here's some practice conversions. We talked about how to do these in class. And you should have them in your notes from Friday, but just in case you don't. So the first one is 32 kilometers to nanometers. And so to convert from kilometers to nanometers, if we go back up here to our metric prefixes, we can see that kilometers means 1,000 meters, and nanometers means 1/1000th of a meter, or 0.000000001 meters. So we can use those relationships to do the conversion. So here's our two conversion factors. We know that 1,000 meters is equal to 1 kilometer, and we know that 1,000,000,000 nanometers is equal to 1 meter. So hopefully you can see, we talked about this in class again, hopefully you can see that there's a connection between kilometers, which is what we're starting off here, and nanometers, which is what we're supposed to end up with. And that connection, that middle point, is meters. One example I gave in some of my classes is, imagine you were on one side of a river over here, and you're trying to get over there, and you have to hop onto this rock, onto this branch, and then onto this rock. Well, you have to take one step, then a second step, then a third step, and then a fourth step. That's kind of how these unit conversions are. Sometimes you have to take multiple steps to get from where you started to where you want to finish. So With this, I'd start off with the number that I'm given, 32 kilometers, and then I'd set up my conversions. And so I would think about, I'm not going to do the whole thing, but I would think about, how do I get from here to an answer that's in, what am I supposed to be answering? Oh, an answer in nanometers, all right, certain number of nanometers. So first I'd think about, okay, let's go from kilometers, which is the unit we're starting with, to something else that's closer to nanometers. Nanometers are small, kilometers are big. Meters is something in between kilometers and nanometers, so let's go there. So to convert, I want to get rid of the kilometers. So where do I put the kilometers here? Numerator or denominator? Denominator. Which means I put the meters in the numerator. Now I'll fill in the numbers for my conversion factor. It's 1,000 meters is equal to 1 kilometer. And if I was then trying to go from, actually let me back up a little bit so the kilometers will cancel. And now if I'm trying to go from meters, which is now the new unit that I have, to nanometers, I want the meters to go away. So I put those down there, nanometers on top. You can fill in the numbers, you can finish the math, and then see what the answer is. But hopefully you can notice that the meters are going to cancel, leave me with just the unit that I wanted, nanometers. And I just have to do the math. I have to multiply, maybe I have to divide, and then I can solve the problem. That's how you do this one. It's also how you do this one. This one has an extra conversion in there. You should have this in your notes as well. You have to go from light years to then meters, from meters to kilometers, and then from kilometers to miles. So it's 4 steps. Powers of 10. I put this link. I put a link to this on the website. Basically, just write down the powers of 10. You know, 10 to the 23rd, 10 to the, I forget what this one is, 10 to the 16th. So these are smaller than a meter. So there'll be a negative exponent, and then a little bit of comparison here. Notice my cursor changes. This is an active link. So if you pull up this document off my website, you can just click on this, or I separately place the link on the website for day 9. Precision and accuracy, I think everybody can handle these just fine on their own. The thumb ruler. So I asked you to measure the width of your phone. All right, this originally said computer screen, but I changed it to say phone. So basically make a thumb ruler. I put a tick mark right over there, and then another one there, another one, another. So this is about 5.5 thumbs for me. And then I want you to, before you stick this on your phone or stick your phone next to this, I want you to guess how wide is your phone. Now you might need to do it twice, or you might actually decide, instead of measuring the length of your phone, maybe you measure the short dimension of your phone, the width, and do it that way. That's fine. Either way, I want you to eyeball it and then include some uncertainty in your guess. I think it's about 5 thumbs, but I might be off by half a thumb. So that'd be 5 thumbs plus or minus 0.5 thumbs. Okay? And then compare what you thought your answer was with what it is. This is a comparison between 2 different rulers. Here we have one with lots of little tick marks, and here's one with only centimeters. So this one looks like it has centimeters and millimeters. This one just has centimeters. You have to compare those. Think about what that means. Here, this says measure the computer screen, measure your phone again. But with these, think about that. Let's see, what else? Oh yeah, this says to measure with a metric ruler. I'd actually hoped to do this in class, but we ran out of time. So if you have a ruler at home that is metric, then you can use that. If not, you can use this and use it a few times, like move your phone across the screen until you get it. What else? Perception. This is great. So we'll do the first one together, and then you can do the rest on your own. So the idea here is that sometimes we see things and we think they appear one way, but really we're seeing, our eyes are tricking us a little bit. So for the first, it says, which appears to be the tallest, A, B, or C? So here's A, B, and C. So you write down which one you think is the tallest, and then you're supposed to measure it. When you measure these, you'll notice that they are all, let's see, here's my tape measure. I don't have my metric ruler on me, but when you measure these, there we go. You can see the height there. You can see the height there, and you can see the height there. So hopefully you notice something about the height. Now, this question is actually a little bit deceptive because this is a, I forget the name of the drawing, but it's a perspective drawing that everything disappears into a single point in the distance. And so, normally with drawings like this, what happens is as things get farther away, they get smaller, just like this sidewalk is getting smaller as it gets farther away. So it's a little weird to me that the authors of this handout didn't do that with these telephone poles. Normally these telephone poles would all follow along this little line right here, and they would start to shrink as they get into the distance. So it's a little bit tricky that they didn't do that in this picture, but they didn't do that. So think about what your brain sees. Think about what your instinct says in terms of which of these is the tallest, and then measure them. The other ones don't have any of those perspective or drawing oddities like this one does, but they do still play some tricks with your brain, right? Like which of these is longer and what's happening here. So answer the questions and then think about what your conclusions are, and that's it. And if you have questions, you can send me a message on the Remind app. And I'll see you all on Monday.